So we have seen how the ideas of whole numbers extend into decimals, whether that's with the standard algorithm or of adding and subtracting or even multiplication. But now I want to highlight, circle back around and show how these same exact ideas of place value and regrouping connect to those different bases that we started with at the start of the semester, right? So one base that we looked at was base 5. And so when we think about base 5, what this means is that we have numerals 0, 1, 2, 3, and 4, right? As soon as we hit 5, we create a new group, right? And so that is our group or bundle in, in sets of 5. So think about base 10, right? This is our current base, our number system, right? We have the numerals. We have 10 numerals, right? 0 through 9, and we regroup or bundle each place value in sets of 10, right? Or our place values are powers of 10 is another way, right? We talked about that earlier in this exact lesson. So that's going to be the same thing with whatever our base is. So in this case, if we're in base 5, then our place values are powers of 5. And so this is important, not only for understanding base 10 and how base 10 is powers of 10, whether those are positive powers, right, bigger numbers, or negative powers when you get into the decimals, but it helps to really solidify this understanding of place value. And so you can add, subtract, multiply, divide, do all of 4 of these operations in the same exact ways, as long as we are regrouping in these sets of 5. And so think about if we had, right, say the number 3, 0, 2, 1, 1. That's a big number. We would call that 30,211. But in base 5, which you can see written as, right, the number with the subscript of the base, this is our 5 to the 0 power, right, our 1s. This is our 5 to the first power, our 5s, right? We would call them 5s, not 10s. This is we would call hundreds, right? But this is our 5 to the second power. This is our 5 to the third power. And this is our 5 to the fourth power, right? Each of our place values correspond to a power of 5. And so as we, right, move up, it's not times 10, but times 5, right? Times 5, times 5. Likewise, and I should have changed the colors. Right, as we move left, we're getting bigger by a power of 5. So these are 5 times bigger than the one before it. Or likewise, you can divide, right, if you're moving to the right. So I want us, so again, depending on the base, this is true only times 5 because we're in base 5. If we were in base 7, these would all be, powers of 7. So these are powers of the base. If we were in base 9, they would be powers of 9. If we were in base 35, they'd be powers of 35, right? So that's really important for us to just continue to remind ourselves, because again, we're in base 10, so we're in powers of 10. And so I want to just share one example, or maybe more than one example of adding and subtracting in such a base. So again, we only have these numerals. So say, could we write, oops, I'm still in the right? 3, 2, 6, 1, 4. Nope. No number 6 exists if we're in base 5. And likewise, if we're in base 7, no number 7 or above. If we're in base 4, no number 5 or above, right? Or even 4. As soon as you hit the number of the base, that's when you start to regroup. So say we have, 100, we'll just do 1, 2, 3, 123 in base 5 plus 321 in base 5. So let's use what we've been talking about with this idea of grouping in sets of whatever the base is to add these numbers. And actually, the way that this works, we don't need to regroup, right? 3 plus 1 is 4, 2 plus 2 is 4, and 3 plus 1 is 4. Sorry, that was a bad example. So let's do 1, 2, 3 plus 422 in base 5. Now what we can see, right, 3 plus 2 is now, I know you want to write a 5, but guess what? Just like the number 10, right, doesn't exist in base 10, right? It's one group of 5 and no ones. Now we have one group of 5, 2 plus 2, and then we got a whole group of 5 and another, and then again, this would be 6. So we have no groups of 5 here and then 2 over here. Or again, you could just write the 2. So this 2000 in base 5 is because we regrouped all of these times. And so another way to think about this, and if you're like, that is, hard to kind of wrap your head around, is that this isn't 2000 as in 2000, right? This is 0 ones, 0 groups of 5, 0 groups of 25 or 5 squared, and then 2 groups of 5 cubed. So how much is that? 125. So I'm running off the page here. And so that's how we compare, right, our place values, or that's how we talk about place values and this idea of regrouping, and why it's so important to understand, right, when we get a full group of 10, we regroup to the next group in our, current base 10 system, versus if we're in a different base, we want to think about whatever the base I'm in this case, right, we were in base 5, so I'm going to write that nice again. And then so in base 5, we regrouped in sets of 5. So try one in a different number base. What would it look like in base 4? What would it look like in base 8? And, maybe we don't know powers of 8 off the top of our head. So try to keep it small, right? 5 is probably one of the ones we can do a little bit easier off the top of our head. So let's do one more example in base 5, and then we'll do one, I wrote 4, in base 4. And it works for adding or subtracting. So again, think of numbers that would require us to regroup, right? We need to add up to 5, but we only have the numbers 0 through 4. So we need 4, 3, 4 in base 5 plus 2, 3, 2. How's that in base 5? Because look, 4 plus 2, I know is 6. So that's, what is 6 in base 5? That's one whole group of 5 and one extra. Right, I know we're used to thinking of, tens and ones, but we kind of have to think about it in the opposite, right? 6 is one group of 5 and one extra. Now, again, 3 plus 3 plus 1 is, again, 7. So how many groups of 5? One group of 5 and 2 extra. And then likewise, 4 plus 2 plus 1 is 2 groups of 5 and 1 extra. And so you write the little subscript. And so here we can think about this as, right, 5 to the 0 power, 5 to the first, 25 or 5 squared, and then 125 or 5 cubed. And if it was a fourth place value, right, then we'd go to 5 to the fifth place value. So try that, make up a base 4, right? Base 5, or try it again. Base 5 only has, right, 0, 1s, 2s, 3s, and 4s. What about in base 4? Well, we have 0s, 1s, 2s, and 3s. So 321 plus 213. How's that sound? All right, 1 and 3 is 4. So, but we don't write a 4 there, right? Because we have, this is a one whole group of 4. So, right, it's 0 left over and one whole group of 4. Again, 1 plus 2 plus 1, 0 left over, one whole group of 4. And now we have 5, 6. So that's one whole group of 4 and 2 left over. And so this is in base 4. This is in base 4. Another way to think about either of these, right? We were talking about when we did our choral count, like 1, 2, 3, 4, 10. Well, that's okay, but we can think about this as maybe not 10, but one group of 5 and 0 ones. And then one group of 5 and 1 1, right? Or, right, we call that 11, 12, 13, 14, not 15, but 20. So this is one group of 5 and 2 left over, one group, one group of 5 and 3 left over, one group of 5, and sorry, these probably could be pluses, and 4 left over. So now it would be one whole group of 5, and then another 5. Oh, well, now that's 2 groups of 5 and none left over. So that's where we get these, right, this numeration. And if we use our base 10, right, we just call this 10 and then 20, it's hard to make sense of that. But if we think about it as groups of 5, right, one group of 5 and what's left over, and likewise, if we're in base 4, it would be the same thing. 1, 2, 3, but not 4, one group of 4 and 0 left over. Then one group of 4 and 1 left over, right? One group of 4 and 1 left over. One group of 4 and 2 left over. Oops, sorry, I know I wrote 0 and I meant to write a 1. One group of 4 and 3 left over. And then it wouldn't be one group of 4 and 4, right? One group of 4 and 4 is two groups of 4 and none left over, right? 2 groups of 4 plus none. So these are just ways to connect our understanding of place value and this idea of each place value is based on, right, the value of each, of each numeral, right, is based on its position in the number, right? Its place. And the value comes from its place that it's in, and that comes from, which power, where the place is, right? Each place value changes, each digit changes value by the powers, right, of the base. So these ones are powers of 5 because we're in base 5. These ones will be, right, powers of 4, 4 to the 0, 4 to the 1, 4 squared. So groups of 4, 4 cubed. Right, base 4 means powers of 4, and our base 10 system means powers of 10, whether again, that's to the left of the decimal or to the right of the decimal. Oops.